Good morning, everyone. Myself, Rohit Kulkarni. Welcome you for today's session. This is Science 1 and topic is lesson number 5, heat. Hmm? As all of you know, in the last two periods, we have seen some of the points. So today, we are just going to continue from there. I will tell you in short what are the points we have seen within the last two periods. In the beginning, we have seen about what is the difference between heat and temperature. We have understood the concept. Then we have seen what is latent heat of vaporization, what is the meaning of latent heat of fusion. Then apart from that, again we have seen Hope's apparatus, which is very important from the exam point of view, the resolution and the meaning of dew point and humidity. Now today what we are going to do, we are going to start from page number 67, unit of heat. So all of you can open your textbook, page number 67, unit of heat. Right, so we'll begin. Now see, what is unit of, we are going to see what are the different units of heat. The units of heat are joule, which is denoted in capital J in SI units, calories in CGS units. Right now, these are the units of heat, joule and calorie. Now, apart from this, erg and kilocalories is also a unit of heat. Remember this: joule, erg, calorie, kilocalorie. These all are unit of heat. So further, we are going to see that how it will be converted. Now, first we'll see what is the meaning of 1 calorie heat definition. So you have to underline the definition and understand the difference between both the definitions: 1 calorie heat and 1 kilocalorie heat. Here, the amount of heat necessary to raise temperature of 1 gram of water by 1 degree Celsius from 15.5 degrees Celsius to 15.5 degrees Celsius is called 1 calorie heat. The second definition is for 1 kilocalorie. Now just see what is the difference. First I will go through the definition, then you can understand. The amount of heat necessary to raise the temperature of 1 kilogram of water by 1 degree Celsius from 14.5 degrees Celsius to 15.5 degrees Celsius is called 1 kilocalorie heat. Right, so if you see the 1 calorie heat, it is in CGS because it is gram, and below whatever 1 kilocalorie heat is there, it is in MK. So both the units you should understand. So this is the difference. The amount of heat necessary to raise the temperature of 1 gram of water by 1 degree Celsius from 14.5 degrees Celsius to 15.5 degrees Celsius is called 1 calorie heat. Similarly, the amount of heat necessary to raise the temperature of 1 kilogram of water by 1 degree Celsius from 14.5 degrees Celsius to 15.5 degrees Celsius is called 1 kilocalorie heat. So from this, what we can say, 1 kilocalorie is equals to 1000 calories, right? All of you know the basic units. Now, for example, 1 kilogram is equals to 1000 grams, correct? In the same way, here the conversion is 1 kilocalorie is equals to 1000 calories. So go through the spelling of joule, calories, and in short form it is written as CAL, or you can write it on the full form CALORI. Full spelling also you can write it, but the short form is CAL. So 1 kilocalorie is equals to 1000 calories. Clear? So the unit of heat is clear for all the students. Now further, we'll just see one more example is given to understand more about it. Suppose if we heat 1 kilogram of water by 1 degree Celsius in different temperature range, then 14.5 degrees Celsius to 15.5 degrees Celsius, the amount of heat required will be different. See what is given. If we heat 1 kilogram of water by 1 degree Celsius in different temperature ranges, we are going to change the temperature from 14.5 to 15. Then the amount of heat required will be different. It is therefore essential to define a specific temperature range while defining the unit of heat. So when we are defining the unit of heat, we need to represent, or we need to define the specific temperature. So calories and joule are related by following relation. Remember this, I had learned it. 1 calorie is equals to 4.18 joule. Underline it, remember, by it, because in it this can be asked for the objective type of questions, that 1 calorie is equals to 4.18 joule. You can repeat it in your mind. 1 calorie is equals to 4.18 joule. So this is the converging the relationship between calorie and joule. Yeah. So here we have completed our first point, unit of heat. Now one more point is very important, which is on page number 68. The activity and the explanation is very important from the exam point of view. So first we'll go through the activity, that is next heading is specific heat capacity. Now see, what is the materials required? A tray with thick layer of wax. So one tray is required. On that, it is fully completed load with the wax. Then solid spheres of iron, lead, and copper. So three spheres are required: one of iron, copper, and lead of equal masses. Means each should have same weight, equal mass. Then burner or spirit lamp and large beaker. So these are the materials we require. Now what is the procedure? First we'll go through the procedure, then we'll see the how it works. Now say take three spheres of iron, copper, and lead of equal masses. So we are going to take three spheres, one of iron, copper, lead of equal masses or equal weight. Put all the three spheres in boiling water in the beaker for some time. So whatever all the three spheres, we are going to put all of them in the boiling water. We are going to boil some water and we are going to put it. Take the three spheres out of the water. All the spheres will be at temperature 100 degrees Celsius. So after boiling, we are going to take it outside. Now all the spheres will be the temperature 100 degrees Celsius. Now as it we remove, put them immediately on the thick slab of wax. As we are removing it from the water, what we are going to do, whatever the tray is there, which is of layer of wax, on the tray we are going to put all the three iron, copper, and lead, all the three spheres, as you can see in the figure. Note the depth that each of the sphere goes into the wax. Now what we have got to do, we have to measure the depth, means which sphere goes very deep into the wax, because all three are rated at a same temperature, right? So this is the activity we have to perform. Now after doing this activity, what are the conclusions? So what the observations we can see? Just we'll go through that. Now see, what are the observations? The sphere which absorbs more heat from the water will give more heat to the wax, correct? So the sphere already which are kept in the water, in the boiling water, which absorbs more heat from the water will give more heat to the wax. More wax will thus melt and the sphere will go deeper in the wax. So the sphere which has absorbed more heat will go more deep into the layer of the wax, or in the wax. It can be observed that the iron sphere goes deepest into the wax. Just look in the figure. Just I will show you the figure. If you see the figure, the iron sphere will go deeper, goes deepest into the wax. And second, lead sphere goes the least. The third one, the lead sphere goes the least, and the copper sphere goes to the intermediate depth. Intermediate, it is in between iron and lead. So the iron sphere goes deepest into the wax, lead sphere goes the least, and the copper sphere goes to the intermediate depth. This shows that for equal rise in temperature, the three spheres have absorbed different amount of heat. Now from this activity, what we can say, even though all the three spheres are heated at the same temperature, but each of them have absorbed different amount of heat. This means that the property which determines the amount of heat absorbed by a sphere is different for the three spheres, and this property is called as specific heat capacity, right? This property is called as specific heat capacity. So from this activity, what we observed, that even though all three spheres, iron, copper, and lead, it is heated at the same temperature, and when it is removed from the water and when it is kept on the layer of wax, we observe that the iron sphere goes into the deepest in the wax, lead sphere goes least, and the copper sphere goes to the intermediate depth. So this property is called as what? Specific heat capacity. Even though there is this shows that for equal rise in temperature, the three spheres have absorbed different amount of heat. Now we'll see the definition of specific heat capacity of the object. So you can underline, which is given in the dark color. The amount of heat energy required to raise the temperature of unit mass of an object by 1 degree Celsius is called the specific heat of that object. So underline the definition. For the specific heat of the object, the amount of heat energy required to raise the temperature of a unit mass of an object by 1 degree Celsius is called specific heat of that object. Clear? So this question can be asked for 3 marks. Huh? So whatever the activity, we have to explain that. And the same question is given in the exercise also. So it is very important. Go through it, write and practice it, and by heart it. Clear? If you write properly, you will get out of what marks for this. Now we'll see the units. So the specific heat capacity is denoted by letter C, small c. Remember this. The specific heat capacity of the object is denoted by the letter C, that is small letter. The SI unit of specific heat is joule per degree Celsius kilogram. Underline and by it. The SI unit of specific heat is joule per degree Celsius kilogram, and the CGS unit is calorie per gram degree Celsius. You can repeat in your mind. The SI unit of specific heat is joule per degree Celsius kilogram, and the CGS unit is calorie per gram degree Celsius. Clear? Repeat in your mind 3-4 times, it will be added. So the SI unit is specifically joule per degree Celsius kilogram, and the CGS unit is calorie per gram degree Celsius. Clear? Now we will see the specific heat capacity of some of the substances. So you can see one chart is given. So 4 examples are given. Substance, specific heat. Then total 8 examples are given. So first is water. So the specific heat of water is 1 calorie per gram degree Celsius. Learn it. Then second example is paraffin. Specific heat capacity is 0.54 calorie per gram degree Celsius. Then third substance is kerosene. Its specific heat is 0.52 calorie per gram degree Celsius. Fourth one is aluminium. Its specific heat capacity is 0.215 calorie per gram degree Celsius. Again, 4 examples are given. Iron, 0.110 calorie per gram degree Celsius. The next one is copper, 0.095 calorie per gram degree Celsius. Silver, 0.056 calorie per gram degree Celsius. And last one is mercury, that is 0.033 calorie per gram degree Celsius. So these are some of the substances and their specific heat capacity. So learn it properly. Clear? Now we'll see next definition. If specific heat of an object is C, already we have seen that specific heat capacity is denoted by letter C, small letter. So the specific heat of an object is C, the mass of an object is m, and if the temperature of the object is raised by delta T degrees Celsius, then the heat energy absorbed by the object is given by m into C into delta T, where m means mass, C means specific heat, delta T means raise in temperature. Remember this. Here delta T means raise in temperature, because 2 definitions are there. Below that also one more definition is there. So you should understand the difference between both the definitions. So if specific heat of an object is C, the mass of an object is m, and if the temperature of the object is raised by delta T degrees Celsius, then the heat energy absorbed, here it is absorbed by the object, is given by m into C into delta T. In the same way, second one, if specific heat of an object is C, the mass of an object is m, and if the temperature of the object is decreased, understood the difference? In the above definition, it is raised, it is decreased by delta T degrees Celsius, then the heat energy lost, yet is lost by the object, will be m into C into delta T. M stands for mass, C stands for specific heat of an object, and delta T stands for decrease in temperature. Right? So both, it looks same, but both have the different meanings. So please go through that, understand the difference between both the definition. The first one is heat energy absorbed, and the second one is heat energy lost by the object. Clear? So this is about specific heat capacity. Now we'll see the next point, that is heat exchange. Page number 69. Now see what is given. If heat is exchanged between a hot and cold object, the temperature of the cold object goes on increasing due to gain of energy, and the temperature of the hot objects goes on decreasing due to loss of energy. Now just you can see the figure 5.10 box of heat resistance material. In that you can see one on two objects are there. One is hot and second one is cold. Now what is the meaning of heat exchange that we are going to see? If heat is exchanged between a hot and cold object, so two objects are there, one is hot and one is cold, and so, suppose if the heat is exchanged, then the temperature of the cold objects goes on increasing. Underline that. The temperature of the cold objects goes on increasing due to gain of energy. Right? So here, whatever the cold object is there, the temperature increases. Why its temperature increases? Due to gain of energy, and the temperature of the hot objects goes on decreasing due to loss of energy, and the temperature of the hot object goes on decreasing due to loss of energy. The change in the temperature continues till the temperature of both the objects attain the same value. Now, what happens? The change in temperature means the temperature of the cold objects increases and the temperature of the hot objects decreases. Now, it's the changing in temperature till it continues till both the temperature objects attain the same value or attain the same temperature. In this process, the cold objects gain heat energy and the hot objects loses heat energy. Right. So in this activity, what happens? The cold objects, it gains heat energy, and the hot objects, it loses heat energy. If the system of both the object is isolated from the environment by keeping it inside a heat resistant box. Now you can see earlier only we have seen about hot objects and cold objects. Now what we are going to do, these two objects we are going to keep in a heat resistant box. Heat resistant means what? That the energy exchange takes place between the two objects only. The outside energy should not enter into the box, right? So if the system of both the objects is isolated from the environment by keeping it inside a heat resistance box, just see what is the meaning of heat resistant box. Meaning that the energy exchange takes place between the two objects only, means between hot and cold objects. Then no energy can flow from inside the box or come into the box. Means no energy will go out of the resistant box and no energy will enter the from outside the box. Right? So in this situation, we get the following principle. So when hot objects and cold objects are kept in a heat resistance box. So what is the principle? Heat energy lost by the hot object is equals to heat energy gained by the cold object. Remember this, and this is called as principle of heat exchange. So after doing this, from this activity, we got the principle of heat exchange, that heat energy lost by the hot object is equals to heat energy gained by the cold object. There, because already we have seen that the temperature of the cold object goes on increasing due to gain of energy. Because cold objects, what it does, it gains energy, and hot energy, what it does, it loses its energy. So heat energy lost by the hot object is equals to heat energy gained by the cold object, and this is called as principle of heat exchange. Right. So this is an activity about heat exchange. Now we'll see next point: measurement of specific heat, mixing method and calorimeter. Now see what is given. The specific heat of an object can be measured using mixing method. Right. So the specific heat of an object can be measured by using mixing method. And please understand properly, because there are some formulas given in below that. For this, calorimeter is used. You have learned about calorimeter in the previous standard. If a hot solid object is put in a water in a calorimeter, heat exchange between the hot object and the water and the calorimeter starts. Right now, what is given here? In the calorimeter, what happens? If the hot solid object is put in a water in a calorimeter, then this continues till the temperature of the solid object, water, and the calorimeter becomes equal. So just it is a revision that for this calorimeter, you have learned about calorimeter in the previous standard. If a hot solid object is put in a water in a calorimeter, heat exchange between the hot object and the water and the calorimeter starts. And this continues till the temperature of the solid object, water, and the calorimeter becomes equal. So therefore, right now see we are going to see some of the formulas. First one, heat lost by the solid object is equals to heat gained by water in calorimeter plus heat gained by the calorimeter. Right? What is the first one? Heat lost by solid object is equals to heat gained by water in calorimeter plus heat gained by the calorimeter. Here, heat lost by the solid object denoted by Q is equals to mass of solid object multiplied by its specific heat multiplied by decrease in its temperature. Similarly, heat gained by the water, that is Q1, is equals to mass of the water multiplied by its specific heat multiplied by increase in its temperature. Then third one, heat gained by calorimeter, that is Q2, is equals to mass of the calorimeter multiplied by its specific heat multiplied by increase in its temperature. Clear? So these are the three: Q, Q1, Q2. Q means heat lost by solid object. Q1 means heat gained by the water. Q2 means heat gained by the calorimeter. So for each one, the formula is given. Heat lost by the solid object, that is Q, is equals to mass of the object multiplied by its specific heat multiplied by decrease in its temperature. Clear? So this is the formula for heat loss by solid object. Now second one is heat gained by the water denoted by capital Q1. The formula for it is mass of the water into its specific heat into increase in its temperature. The next one is heat gained by the calorimeter, that is denoted by Q2, is equals to mass of the calorimeter multiplied by its specific heat multiplied by increase in its temperature. So learn all the three: Q, Q1 and Q2. Then from this what we can say, heat lost by hot object, heat lost by hot object, that is Q, is equals to heat gained by calorimeter Q2 plus heat gained by the water, that is Q1 plus Q2. So Q is equals to Q1 plus Q2. Q means heat lost by hot objects, Q1 means heat gained by the water, and Q2 means heat gained by the calorimeter. So Q is equals to Q1 plus Q2. But to know Q, Q1 and Q2, you should remember all the above formulas. What is Q, what is Q1, and what is Q2. So using this equation, if the specific heat of water and the calorimeter are known, the specific heat of the solid object can be calculated. So by using this equation, Q is equals to Q1 plus Q2. What we can do, we can calculate the specific heat of the solid object. Clear? So this is the formula for Q is equals to Q1 plus Q2, that is heat lost by the solid object or by the hot object. Clear? So these are the some points we have seen today, like unit of heat, then specific heat capacity, the activity which is very important, then heat exchange and measurement of specific heat by mixing method and by the calorimeter. So here we have completed our theoretical part. Now we'll see some of the examples which is given in the textbook, solved examples, which is given on page number 69. Now see what is the first example. So to know the example, to solve the examples, you should know all the formulas from the lesson. So for that, what you have to do, once you have to read the lesson and you have to note down all the formulas. Now see, just we'll go through examples now. What is example one? How much heat energy is necessary to raise the temperature of 5 kilogram of water from 20 degrees Celsius to 100 degrees Celsius? So this is the question. How much heat energy is required or necessary to raise the temperature of 5 kilogram of water from 20 degrees Celsius to 100 degrees Celsius? Now first we'll write what is given. Now here what is given? Mass M is equals to 5 kilogram. Then C, already I told you the meaning of C, specific heat capacity. Small c means specific heat capacity. It is 1 kilocalorie per kilogram degree Celsius. And change in temperature means delta T. That is 100 minus 20. So it will be 80 degrees Celsius. So energy to be supplied to water is equals to energy gained by the water. So the formula is there: mass of water M, specific heat capacity of water C, and change in temperature delta T. So substitute the values 5 multiplied by 1 into 80. So after multiplying, you will get the answer 400 kilocalorie. So hence the heat energy necessary means it is required. The heat energy required to raise the temperature of water is 400 kilocalorie. If value of specific heat is not given, so you can take it is 1 kilocalorie per kilogram degree Celsius, because here it is water. So you can just look in the table. The specific heat capacity of water is 1.0 calorie per or kilocalorie per kilogram degree Celsius. So this is the first solved example. Now if you open page number 70, again two solved examples are there, so we'll go through that, both the examples. See now what is example number 2. A copper sphere of 100 gram mass is heated to raise its temperature to 100 degrees Celsius and is released in water of mass 195 grams and temperature 20 degrees Celsius in a copper calorimeter. If the mass of calorimeter is 50 grams, what will be the maximum temperature of water? So here we have to find out the temperature of the water. Now first we'll write what is given. See now given specific heat of a copper. So the specific heat of a copper is 0.1 calorie per gram degree Celsius. Then specific heat of calorimeter is 0.1 calorie per gram degree Celsius. Suppose the copper ball water and the calorimeter after final temperature T. So after final temperature T, what will the formula? Heat lost by the solid object is equals to heat gained by water in calorimeter plus heat gained by the calorimeter. Now here heat lost by the solid object means heat lost by the copper ball is equals to mass of the copper multiplied by specific heat of the copper into decrease in temperature, means second formula we are going to use. So M into C into delta T, but here delta T means decrease in temperature. So substitute the values. Q is equals to mass is 100, specific heat capacity of copper is 0.1 and change in temperature is 100 minus T. Similarly, now here it is heat lost by copper ball we have written. Now we'll write heat gained by the water is equals to M into C into delta T. So that is Q1 is equals to mass of water is given 195 into 1 into T minus 20 degrees Celsius. So this is increase in temperature. Now third one is heat gained by the calorimeter. So that is M into C into increase in its temperature, that is delta T. So Q2 is equals to mass of calorimeter is given 50 gram into specific heat capacity 0.1 into T minus 20. So substitute the value. So we have seen the formula, last formula. Q is equals to Q1 plus Q2. Now you have to substitute the values. Q means 100 into 0.1 into 100 minus T. Q1 means 195 multiplied by 1 into T minus 20. And Q2 means 50 multiplied by 0.1 into in bracket T minus 20. Now after solving this equation, so all of you know how to solve these equations. Now after solving this equation, we'll get the value of T, that is temperature, is near about 23.8 degrees Celsius. So what we can say, the maximum temperature of water will be 23.8 degrees Celsius. So in this way, we can find out the temperature of water. What is the maximum temperature of water required? Okay. So this is the example number 2. Now one more example is given, solved example. We'll go through that. Example number 3. See what is third example. If 80 grams steam of temperature 97 degrees Celsius is released on an ice slab of temperature 0 degrees Celsius, how much ice will melt? First question. Second one, how much energy will be transferred to the ice when the steam will be transformed into water? So these are the things we have to find out. Now first we'll write what is given. So here what is given, latent heat of melting the ice, that is L means latent heat melting. So here it is 80 calorie per gram. Then latent heat of vaporization of water, LVAP means latent heat of vaporization, 540 calorie per gram. Now solution, mass of steam, m steam matlab means mass of steam, it is given 80 gram. Then temperature of steam 97 degrees Celsius, that is also given. Then temperature of ice, P ice, that is also given, that is 0 degrees Celsius. So these all things are given. Now first what we have to do, heat release during conversion of steam of temperature 97 degrees Celsius into water of temperature 97 degrees Celsius is equals to mass of steam into latent heat of vaporization. So values are given, that is 80 multiplied by 540. So you can multiply, otherwise you can keep as it is. You can write down equation number 1. So it is, you kept as it is, so that will be our equation number 1. Then second one, heat released during conversion of water, above it is steam, here it is water of 97 degrees Celsius into water of 0 degrees Celsius. So m steam into delta T into C. So mass of steam is given 80, change in temperature means 97 minus 0, and C is 1. So after solving that, you will get 80 multiplied by 97. So 97 minus 0 means 97. So that is our equation number 2. Now total heat gained by the ice, that is 80 into 540 plus 80 into 97 from equation 1 and 2. Means from equation 1 and 2, we can solve that 80 into 540 plus 80 into 97. So 80 is common, so you can take it as common and you can add that. So you will get 50,960 calories. Right, so this is what first one, how much energy is. How much energy is required? Near about 50,960 calorie energy is required. Then some mass of the ice, m ice, will melt due to heat gained by the ice. Then m ice into L melt. M ice means, you know, mass of the ice. L melt means latent heat of melting the ice. So that is the short form. So after substituting, that will be equals to 50,960 calories. So after substitute the values and find out the meaning, melting m ice, that is mass of the ice. So mass of the ice will be near about 637 gram. So thus 637 gram ice will melt and 50,960 kilocalorie will be given to the ice. So in this way you have to solve all the examples. But for solving the examples, you should know all the formulas. So that is why I told you, go through the lesson, learn all the, write down all the formulas on one paper, learn by heart it, learn it, and then solve the example. Clear? So here we have completed our this point. So just once again, I will see in short what are the things we have seen. Right? Today we have seen first point is about unit of heat. Right? In the unit of heat, we have seen first what are the units of heat. I already explained you the unit of heat are calorie, joule, erg, and kilocalorie. These are some of the units of heat. So joule is in SI unit and calorie is in CGS unit. Then we have seen the definition of 1 calorie heat and 1 kilocalorie heat. 1 calorie heat means the amount of heat necessary to raise the temperature of 1 gram of water by 1 degree Celsius from 14.5 degrees Celsius to 15.5 degrees Celsius is called 1 calorie heat. Then we have seen the definition for 1 kilocalorie heat. The amount of heat necessary to raise the temperature of 1 kilogram of water by 1 degree Celsius from 14.5 degrees Celsius to 15.5 degrees Celsius is called 1 kilocalorie heat. Then we have seen the conversion that 1 kilocalorie is equals to 1000 calorie. Again, we have seen one more relation between calorie and joule, that is 1 calorie is equals to 4.18 joule. 1 calorie is equals to 4.18 joule. This is the relationship between calorie and joule. Then next point, which is very important, as already I told you, that is specific heat capacity. So you have to write down all the explanation. Just I will tell you once again in short what are the materials required here. We have taken a tray of wax and three solid sphere, one of iron, copper, and lead. Then burner of spirit lamp and large beaker. So first we are what we have done. We have taken three spheres of iron, copper, and lead of equal masses. Put all the three spheres in the boiling water and heat it up to temperature 100 degrees Celsius. We are going to remove it from the water and we are going to put it on the wax tray of wax. Now after putting it on the wax, what we will observe that the sphere which absorbs more heat from the water will give more heat to the wax. Now more wax will does melt and the sphere will go deeper. So the sphere which has absorbed more heat will give more heat to the wax and the sphere will go deeper. So after doing this activity, we have seen that the iron sphere goes deepest into the wax, lead sphere goes least, and the copper sphere goes to the intermediate depth. Intermediate depth means in between iron and lead. So for equal rise in temperature, the three spheres absorb different amount of heat. Clear? So from this activity, what we understood that for the equal rise in temperature, three spheres have absorbed different amount of heat, and this means that property which determines the amount of heat absorbed by a sphere is different for the three spheres, and this property is only called as what specific heat capacity. So after doing this activity, we have seen the definition also of specific heat capacity. The amount of heat energy required to raise the temperature of a unit mass of an object by 1 degree Celsius is called the specific heat of an object. Hmm? When the specific heat capacity is denoted by the letter C, small c. Then we have seen its SI unit. Its SI unit is joule per degree Celsius kilogram. Underline and remember it. Already I told you. There is CGS unit is calorie per gram degree Celsius. Right. So these are the points we have seen. Specific heat, its formula, its definition, its unit. When we have seen some of the substances, for example, water 1.0, paraffin 0.54 calorie per gram degree Celsius, then kerosene, aluminium, iron, copper, silver, mercury. So these are some examples are given, and their specific capacity is also given. So go through that. And then after that, we have seen two definitions. When the what happens if the energy is the heat energy absorbed and when the heat energy is lost. So if the specific heat of an object is C, the mass of an object is m, and if the temperature is raised by delta T degree Celsius, then the heat energy absorbed by the object is given by m into C into delta T. Delta T here means rise in temperature. And second one, in the same way, if specific heat of an object is C, the mass of an object is m, and the temperature of the object is decreased by delta T degree Celsius, then the heat energy lost by the object will be m into C into delta T. But here delta T means decrease in temperature. And this both the formulas we have used while we are solving the example. And afterwards, we have seen about heat exchange. Then we have seen about what is how heat is exchanged. So just I will tell you in short that if heat is exchanged between a hot and cold object, the temperature of the cold objects goes on increasing due to gain of energy, and the temperature of hot objects goes on decreasing due to loss of energy. This is the main point. Clear? The temperature of the cold object goes on increasing due to gain of energy, and the temperature of hot objects decreases due to loss of energy. And till this change in temperature continues till both the hot object and cold object attain the same value. But if we are keeping this in heat resistant box means that energy exchange takes place only between the hot objects and cold objects. There no energy can come inside and no inside the box and cannot go outside the box. And after doing this activity, we have got the following principle of heat exchange, that is heat energy lost by the hot object is equals to heat energy gained by the cold object. So this is called as principle of heat exchange. And at last, we have seen the measurement of specific heat, that is mixing method and calorimeter. So from that different formulas we have seen what is meaning of Q. Q means heat lost by the solid object. Q1 means heat gained by the water, and Q2 means heat gained by the calorimeter. And for that also formulas are given. The formula for Q, formula for Q1, and formula for Q2. At last, we have got the formula Q is equals to Q1 plus Q2. Q, heat loss by hot object. Q1, heat gain by the water. And Q2 means heat gain by the calorimeter. And using this equation, if we know the specific heat of water and the calorimeter, then the specific heat of the solid object can be calculated. At last, we have seen 3 examples, solved examples. So go through that all the solved examples which is given in the textbook, and whatever the exercise is there, we'll see in the next page. Clear? So hope so all of you understood whole lesson from beginning, whatever the points we have seen within these 3 lectures. So what you have to do, you have to read a whole lesson once again. You have to understand the concept. Clear? At last, just we'll go through the evaluation part. The first question is, what is the unit of heat? So if you know the answer for the first question, you can raise your hand and you can answer it. What is the unit of heat? Dear students, if you know the answer, some questions are given. Are they on your on the slide? So answer the first one. What is unit of heat?
Good morning, sir.
Good morning. You can answer the first question.
So the first answer is unit of heat are joule in SI unit and calorie in CGS unit. So can I give third one answer too?
Wait, I will tell you now. Just I will repeat. The first question for the first answer is the SI unit is joule and the CGS unit is calorie. Clear? Now, apart from that, 2 units are also there. One is erg and kilocalorie. So that also can be written. So second question is define 1 calorie heat. Those who know, you can tell the definition.
So what is third one?
Wait. First we'll complete the second one, dear. Then you can tell the third one. First we'll complete second one. Define 1 calorie heat. You can try it. You have to tell the definition.
1000 cal.
But you can say. Define 1 calorie heat. Anyone is there? Those who knows the answer for the second question, define 1 calorie heat. Otherwise, you can say the third. You can continue here. You can say that.
So the amount of heat necessary to raise temperature of 1 gram of water by 1 degree Celsius from 14.5 degrees Celsius to 15.5 degrees Celsius is called 1 calorie heat.
Okay, very good. It is correct. In the same way, you can write also definition from 1 kilocalorie heat. Very good. Third one, 1 kilocalorie is equals to how much calories?
1000 calories.
Okay, very good. 1 kilocalorie is equals to 1000 calories. Now, last question, define specific heat of the object or define specific heat. Just you have to tell the definition. Define specific heat. Anyone can try? Okay, right. So what you have to do, just go through all the definitions, all the questions, whatever given. In the next page, we'll see the question answers which is given in the exercise. Clear? Okay. If you have any doubt, you can ask it. Yes, what happened?
The last answer is the amount of heat energy required to raise the temperature of a unit mass of an object by 1 degree Celsius is called the specific heat of that object.
Okay, very good. It is correct. Okay, nice. Right. So thank you, students. If you have any doubts, you can ask it. In the next period, we'll continue with our exercise questions which are given in the exercise. Thank you.
Okay, thank you, sir. Thank you very much.
Thank you, ma'am.
Yeah, students, please revise the topic which is being taught today. We'll wind up the session over here. Can we stop here, sir?
Yes, ma'am. Yes, ma'am. We can stop.
Okay, thank you so much.
Thank you.